Okay. Okay, let's just start. Yeah. Okay. Okay, so like I said, this is just a demonstration video. So this is going to be the first part of many. So we're going to be starting with AP Stats Chapter 1. And so today we're just going to be talking about centers, spread, and variability, quartiles and IQR, and lastly, standard deviation and variance. So let's start with center, spread, and variability. So basically, we're going to be talking about how you would describe distributions. So first, let's start with, when describing a distribution, we have to look at 4 different elements, which are, we use the abbreviation SOX to help remember it. So the first one, I'll just show you all of them. The first S stands for shape, the O stands for outliers, the C stands for center, and the S stands for spread. So when we're talking about the shape, we basically look at 3 different types of shapes. And here they are. So a normal, if a distribution has a roughly symmetrical shape or a normal shape, the curve looks roughly symmetrical, just like this. If the distribution is skewed to the left, the curve will look like this, and if it's skewed to the right, it'll look like this. And I'll show you how to tell just by looking at a graph if it is skewed to the left or the right. So next up, outliers. Outliers is when you are looking at a set of data and the points of data are outside of the typical pattern. So we'll worry more about calculating those later in a different part, but for now, anything that's noticeably outside of the pattern of data is considered an outlier. So the center is considered to be the midpoint of the distribution, aka the median. And lastly, the spread is the range of a distribution. So like, I'll give an example in a second, but let's go ahead and look down here. So here we have a dot plot showing package weight in ounces. So here we can see multiple different points of data. So let's begin by looking at how we would describe this distribution. So the first element, the first S, is for shape. So if we look at the shape and we look at the data, we can see that it has a curve roughly like that. Sorry for the weird curve, but if you look at this, this is normal or roughly symmetrical. So for the shape, we can say this is roughly symmetrical. So let's look at outliers. Like I said, we don't know how to calculate them yet, but just by looking at this data, it doesn't look like any data is outside of the typical pattern. So I think it's safe to say that there are no visible outliers in this distribution. Next, we can look at the center. This is the median of the distribution. So just without actually looking at too much, I can just tell that the center is about right here, where all these numbers are clustered at 16.6 ounces. So I think it's safe to say that the center is about 16.6. And lastly, we'll talk about the spread. So when talking about spread, you're going to talk about where the different points of data range from. Let me just check the chat real quick. Okay, cool. So anyway, sorry. When we talk about the spread, we're going to range from where the data range is in the distribution. So in this case, we can see that the lowest point of data is at 16.1 and the greatest is at 16.9. So we can say that in this distribution, the data vary from 16.1 to 16.9. And you can also talk about the range, which is equal to 16.9 minus 16.1, or the maximum minus the minimum. So let's continue and by looking at one more example. So here we have a simple dot plot of excused absences. So again, let's begin by looking at the shape. If you look at this curve, it's about like this. It's a really good drawing. But if you look at that, you can see that that's clearly skewed to the right. So you basically just make the curve by just going up and drawing it like that. I don't know how to explain it. You can kind of just see from that. So again, looking at outliers, there's no visible outliers. Everything seems to stay within the typical pattern. The center looks to be around somewhere within this range, so probably around 1. And lastly, the spread, the data ranges from 0 to 5. So like I said, just going through this really quickly, just a light review. So now let's talk about quartiles and IQR. So quartiles are pretty simple. Let me show you the definition of a quartile. So the definition of a quartile is quartiles, the purpose of a quartile is to separate the data into 4 sections, which each contain an equal amount of data. So let me see. So let me just show you this one real quick. This is pretty much an example of where different quartiles are in a set of data. So here is the first quartile, which separates the data here. The second quartile, which is also the median, which separates it right here. The third quartile right here, and fourth quartile is the very end of the data, right? You don't need a fourth quartile there. Sorry, there are 3 quartiles. So let's find how to find the quartiles. So quartile 1, it's basically the median of all data to the left of the median. And we'll go into some examples in a second. The third quartile is the median of all data to the right of the median. And then finally, the interquartile range, or the IQR. And now this is basically the range between the 2 quartiles, and like I said, the interquartile range. And it's calculated as quartile 3 minus quartile 1. So for example, if we were to look at this data, you would see that the third quartile right here is equal to 90, and the first quartile is equal to 70. So we'd subtract 70. And this is equal to 20. Sorry, Google Drawing is a little funky. So in this set of data, the IQR is equal to 20. But let's look a little deeper into where the quartiles come from. So if you look at this set of data, there are 10 numbers, okay? Now, when you have an even amount of data and you're trying to find the median, you have to find the average of the middle 2 values. In this case, since they're both 80, we can just say that the average is 80. Now, this is interesting because the quartile is not on a number itself, but it's in between the 2 numbers. So keep note of that. Whenever you have an even amount of data, the second quartile is always going to be in the middle of 2 points of data and not actually on top of one. Then after that, we look at all the data to the left, and you see there are 5 points. So the first quartile would simply be the median of this data, which is 70. And then when you want to find the third quartile, you look at all the data to the right, and the value in the middle is 90, so that's the third quartile. So then, once again, let's move on to the next example. Sorry, I'm just periodically checking on the chat. All right, more viewers than I thought we'd have. Okay, so let's move on to example 2. So in this example, we have this data, heights in centimeters, and we have it right here. So if you count up the data, you see we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And sorry about like the bad writing. I don't have like a pen tool or anything. I'm just writing with my mouse. The pen tool isn't really working, so I'll look into that later. But anyway, so here we have 11 points of data. So when you have an odd number of data, obviously all you have to do is look at the middle, which in this case is 6. So the median is 7. So I'll just write it here. Median, I'm just going to abbreviate it as MED is equal to 7. Okay, so then we're going to look at all the data to the left to calculate the first quartile, and we'll see that quartile 1 is 6. Because there's that, and then when you look at all the data to the right, you see that this is quartile 3 is 11. So lastly, IQR is equal to 11 minus 6, or 5. So pretty simple. We can talk about it more later, but let's just move on to the next and final part of this short demonstration. We're going to talk about standard deviation. So ignore this example problem. We're going to talk about that at the end. But basically, we're going to be talking about standard deviation, like I said. So the definition of standard deviation. It is the measure of the typical distance between the values in a distribution from the mean. So the best way to understand this is to just look at how it's calculated, and yeah. So let's look at the formula. So here it is. For those of you who haven't seen it before, try not to be overwhelmed. It's really not that bad once you look at it. So, whoops, hold on. So first, let's begin. So this S of x, which is standard deviation, is equal to the square root of this symbol, which, for those of you who don't know, this symbol is equal to summation, which is just adding all the values to depending on these inputs. So in this case, we have our variables defined. N is equal to the number of data points. X with the line over it is equal to the mean of the data, and xi is equal to each of the values of data. So when we look at this, basically what this is the square root of the sum of each point of data minus the mean of the data squared. So basically, and then divided by the number of data minus 1. Now, the reason why we subtract 1 is because in these examples, the standard deviation is not representative of the entire population, and it's just a sample, which is something that you'll learn in chapter 4. So, sorry, I'm just keep checking on the chat. I mean, there's not much going on there, but. Okay, so as an example, let's just look at this right here. So we have the points of data 4, 8, 2, 1, 7, and we want to find the standard deviation. So all we're going to do is we're going to take the square root. The square root of 4 minus the mean, which I'll let you calculate that yourselves if you are interested in doing the problem, squared plus the next point of data, which is 8. 8 minus the mean squared. Let's just keep this going. Plus, and you do this for all points of data. Sorry, I'm trying to do ellipsis. And you divide the whole thing by the total data minus 1, which is 5 minus 1, which is equal to 4. So then you basically do this, and you get the standard deviation. So, like I said, pretty simple. And then lastly, we'll talk about variance. Variance is simply the standard deviation squared, S of x squared. Yeah, at this point, I would answer any questions people had, but I'm assuming no one's gonna have any questions because we already learned this. Yeah, I know my handwriting is great. Well, yeah, so